So we looked in our last notes about cotangent and tangent, and they were a little bit different just because they have asymptotes, which is different than our sine and our cosine. For our last two, remember we have secant and cosecant, and they're going to have asymptotes like our tangent and our cotangent did. However, we want to base our graphs off of our sine and cosine graphs. So remember that. So cosecant of theta is 1 over sine of theta, and secant of theta is 1 over cosine of theta. And that's important because that tells us where our asymptotes are. So notice that, like on my first one, I have a sine in the denominator, which means that I'm going to have asymptotes when sine of theta equals 0. Likewise, on my second one, I'm going to have asymptotes when cosine of theta equals 0. So, because our graphs are going to be so closely related to sine and cosine, what we do instead of trying to memorize another parent graph, we're going to take our sine and our cosine graphs, graph those first, and then basically look at, okay, where do these graphs equal 0? And then we'll basically turn that into our secant and our cosecant graph. Does that kind of make sense? Okay. And then because they're so closely related to our sine and cosine, the period of both of these graphs is going to be 2 pi, just like they were with our other ones. So this is kind of what they look like. So if you notice the light gray graph is going to be our sine graph and then our cosine graph. So then notice that wherever we have our zeros is where we have those imaginary lines then that become our asymptotes. And then because remember asymptotes are like our black holes, they suck our graph towards them, okay? So notice that basically what happens is in between each of those asymptotes, our original graph just gets flipped. So here, my maximum gets turned into a minimum for my new graph. And then likewise, if I have a minimum, it gets turned into a maximum for my new graph. And then the same is going to be true for our secant graph. It's just going to be based upon our cosine graph now instead. Okay, so when we're looking at these examples, we start with 2 cosecant of x plus pi over 4, right? And so like I said, instead of trying to think about, okay, what's the cosecant graph going to look like, we're just going to go ahead and look at our sine graph first. So we're going to look at what we call the associated sine graph. And basically, I'm just going to change the function to sine instead of cosine. Does that make sense? And then we're going to graph it just like we have been graphing our sine and cosine. Nothing about that really changes. So remember that we want to label all of our stuff first. So our A value here is 2, so that's going to affect our maxes and our mins. We don't have a B value, so our period is just going to be 2 pi. And then notice that we have a phase shift of pi over 4. So then remember that we can find the starting spot by taking our insides, which in this case is going to be that x plus pi over 4, and we set that equal to wherever we normally start our graph. So for Sine, we normally start at 0, so that's what we're going to set this equal to, and then we just solve for x. So notice that we get x equals negative pi over 4. Then to find the end, we take our starting position and then just add our period, which in this case was 2 pi. So because we have a fraction, we have to find a common denominator. And we end up with 7 pi over 4. So then I'm just going to label my graph like I would normally. So I'm going to go by like 1/2 on my y-axis. And because we're looking at like things that have pi's over 4s in them, I'm going to go ahead and label my x-axis by pi's over 4s. So we know that for sine, it's going to start and end at a 0. So since I'm starting at negative pi over 4, I know I have a 0 there. And we're ending at 7 pi over 4. So that's going to be here. And then we know exactly halfway in between is going to be our other 0. Then remember, halfway in between our first two zeros is normally where our maximum occurs, which is usually at 1, but because we have that a value, it's going to get shifted to 2. So we'll be here. And then our minimum is going to be very similar. Instead of at -1, we're going to be at -2. So that is what our sine graph looks like. But remember, they don't actually ask us to graph our sine graph. They ask us to graph the cosecant graph. So what we're going to do is then just use those graphs and those couple of key points that we talked about on the previous page. So I know for my cosecant graph, anywhere that I have a 0, it becomes an asymptote. So I'm just going to draw my imaginary lines through my zeros, because those will be my asymptotes. And then remember, we said that basically everything gets kind of flipped from that sine graph. So here at pi over 4, I have a maximum. Well, that's going to become a minimum for my new graph. And I know that my graph has to be in between my two asymptotes. And then at 5 pi over 4, instead of a minimum, now we have a maximum for my new graph. And again, my graph is going to go towards my asymptotes on either side. So it's not really like memorizing a new graph. It's just knowing how to take our sine graph and then translate that to what the cosecant graph would be, which is a much easier process than just trying to memorize all of the new stuff. Questions? Alright, and then lastly, we have one with secant, and this is going to be very similar. The only difference this time is we're going to use cosine instead. But just like before, I'm going to look at the associated cosine graph. So the only thing I do is I switch my secant to cosine, and then I find all of my things the way that I normally would. So my a value is 1 this time, so my max and my min haven't been affected. This time, we do have a b value, so we're going to do 2 pi divided by 2. So we just end up with pi. We don't have any phase shifts, but we could go ahead and set our insides equal to 0. So we do end up, we're starting with at 0. And then to find our ending spot, remember we take our starting spot, add the period, so it will be at pi. So again, I'm going to go ahead and just go by 1/2 on my y-axis. And then on our x-axis, since we have to go out to pi, we can go ahead and still go by pi's over 4. Just because that gives us 4 spots will be pi. So it still gives us a good spot to end. So remember, the only difference is that instead of starting at a 0, cosine starts at a maximum instead. So for this, since we didn't change our amplitude, our maximum is going to be at 1. Then we also know that we'll end at a maximum, which is going to be at pi this time. Halfway in between, which is at pi over 2, I have my minimum. And then halfway in between each of those, we have our zeros. So that's our associated cosine graph. And then just like before, basically we're just going to flip that into our secant graph. Because in the end, that's the graph that we're actually wanting to get. So I'm going to draw my asymptotes through my zeros. And then I'm just going to flip each of my maxes or mins. And my orange graph would be the graph that we actually want to have. So like on your homework, I would suggest either using like a different color or even just like not drawing it as dark and going ahead and graphing either the sine or cosine. But then just make sure that either you switch colors or that you make it darker, your final graph. That way I can tell like which one is your final